Hi, class. Here is your lecture for chemistry on Wednesday, January 6th. Today, we're going to talk about the periodic table, our new unit here, Unit 5 on the periodic table, and you will definitely need a copy of the periodic table. So hopefully you still have the one that I passed out at the end of last quarter. If you do not, there is one in yesterday's Schoology folder. You can print that one out and use that. But you will definitely be needing that periodic table today. So what is the periodic table of the elements? Well, first we have to understand, what does the word periodic mean? Periodic, right, has a regular and repeating pattern. Makes sense. We talk about periods of the school day, first period, second period, third period. It repeats every day, every school day, right? We have a first period, second period, third period. So it has a regular and repeating pattern. Now, Dmitry Mendeleev is the man who was given the most credit for coming up with the idea or the concept that we needed a periodic table. And if you look at this, 1869, so this is what, 150 years ago, really not all that long. So he was the one, like I said, he was the one credited for coming up with the idea of the periodic table. And his version of the periodic table looked something like this. Now you notice it is very, very different than what we have today. And you'll see that he's got things that tend to be arranged in columns here. And you look at the numbers that he has, so that things are highlighted in yellow. So we've got hydrogen over here with a 1, beryllium with a 9.4, boron with an 11, carbon 12, nitrogen 14. So we have these things that are fitting in here. And they kind of tend to fit together. He's got lithium over here as 7. So if you notice, each column, right, it has a range of numbers, and he puts these all in here. So he was trying to arrange them by columns. And there's just some common ones that you might know: aluminum, uranium, silver. And he's trying to put these all in here. Now, he based these on properties. And like I said, one of the properties was increasing atomic mass, but they also shared other similar properties. You saw repeating in a periodic way. You saw them repeating over and over. So like I mentioned, they're organized by extending mass within a column, but things that are in the same row had similar chemical properties. Now he left some blank spaces in here, you see, right? He left these blank spaces in here for undiscovered elements. We didn't know that these elements, what these were. He knew that there was something here, for example, that was 68, but we didn't have a name for it. But here he had blanks in here. We didn't know what these elements were. We didn't have any idea. But he could predict what they were, what their properties would be, and even predict their masses. So let's get into the periodic law. What is the periodic law? Now, what have we changed between what Mendeleev's table is and what we have? And the big thing we changed is we organize the elements by the number of protons, not by their mass. And if you remember from our previous unit, the mass of an atom is not only dependent on the number of protons, but also the number of neutrons, right? Number of neutrons. And we see that from a chemistry perspective, it's the number of electrons that really drive what's going on, and our electrons are paired up with our protons. So what shouldn't be the mass that's the important part, it's the number of protons that are the important part. And that gives us rise to the periodic table that we have here. And here's just kind of a picture, and we'll talk about some of this more next week when we start talking about periodic trends. That's what some of the trends are indicated on this picture. But what we see is that the properties of elements are going to change with an increasing atomic number in a periodic way. Right? A periodic way. If we look at this table, up at the very top here, we have this blue arrow pointing to the left. It says atomic radius increases. So as you go from the right side to the left side, it increases. That's one of the periodic trends, the periodic things that we see, regular repeating pattern that we see on the periodic table. Again, we'll learn about those trends a little bit more next week. But first, back to the basics of a periodic table. So you have a blank periodic table that is in today's folder, and the vertical columns we're going to call our groups. So on that blank periodic table on the front of it, I want you to put groups, label that as your vertical columns. And these are elements that have similar physical and chemical properties. Anything falls in that same column, anything falls in that same group, has similar physical and chemical properties. So if you look at your periodic table, You look at that first column, hydrogen, lithium, sodium, potassium, rubidium, cesium, and francium. Those all have similar physical and chemical properties. Right, so I'd want you to label here on your blank periodic table, right? I want you to put groups here kind of on the bottom left and make it vertical, so it's representing that groups go up and down. There are columns, there are vertical direction. And next to that, write similar chemical and physical properties. Now I'm putting in group headers or column headers here, 1A and B. We're going to ignore the B's. That's this group here in the middle for a moment. We're going to focus on the ones that are labeled A. So 1A is our first group, our first column. And how do we label our groups? We're going to use Roman numerals. And we need to know our Roman numerals from numbers 1 to 8. Right? So number 1 in Roman numerals is a 1. Number 2 in Roman numerals, it's the 2 I's put together. 3 is 3 I's. 4 is an IV, right? So hopefully you guys have seen Roman numerals before. If not, I'm just going to go through them very quickly. 5 is just simply the V. Think of that IV, that I means in front of the V. It's 1 less than a V. 1 less than 5 is a 4. If the I comes after the V, that means we add it. So VI, 5 plus 1, that's 6. VII, 5 plus 1 plus 1, that's 7. And then we're going to go up to 8. VIII, that's 8. And that takes the 8 that we're looking for. So we're going to label our periodic table. This first column here is column 1. We label that with an I. Our second one we put with 2 I's. That's column 2. And then similarly, we're going to jump across these ones in the middle. There's got a B there. We'll explain that later. 3, and then 4, 5, 6, 7, and 8. So our far right one is column 8. Our far left one is column 1. And this is going to drive a lot of similar chemical and physical properties, at least the ones with the A's. The B's here in the middle are going to be a little bit different. And again, we'll hold off on that. Label those columns on your blank periodic table. Now, in addition to the groups being our vertical columns, we have periods, and these are our horizontal rows. And again, these follow a repeating pattern. So you see that same change going across. So back to our blank periodic table, I want you to put periods here, if you kind of use that P for groups to be your start for your periods, and having periods go left to right like a row. And periods follow a repeating pattern. So this is how I want you to take your notes for this on your blank periodic table. Now, for periods, we use regular numbers. 1, 2, 3, 4, 5, 6, 7. So if you see there in the left margin here, I got those numbers here, 1, 2, 3, 4, 5, 6, 7. So we have 7 periods, because we have 7 rows. These 2 down here in the bottom, we'll explain those again later. They're kind of an exception. But we have 8 columns, 8 groups. So now I want you to put that information on your good periodic table now. Right, your good periodic table, the one that I handed out originally. So it has the name, the element symbol, the atomic number, atomic mass, all that good stuff. I want you to label those. Put your group numbers across the top, the Roman numeral 1, Roman numeral 2, Roman numeral 3, all the way to 8, and put your row numbers, your period numbers along the left, 1, 2, 3, 4, 5, 6, and 7. Pause the video for a moment while you do that. Now, if you remember yesterday, I asked you to kind of color in your good periodic table. Remember our green was our metals. And what do we mean about our metals? Let's give you some characteristics about our metals. Metals, they're good conductors. Right? We're used to that. We want to conduct electricity. We can use copper, gold, silver. Those all work very well. They not only they conduct electricity well, they conduct heat well. Right? And metals are typically shiny. Right? You think of silver, gold as being shiny metals. Malleable means that you can you can dent them, if you will. Right? You can take a hammer and you can dent them. Right? Ductile, you can shape them, so we can bend them. Right? We can easily take a wire, a piece of metal that's in the shape of a wire, and we can bend it into different shapes. Right? We could take a hammer, we could smash it from being a round wire into a flat strip of metal. That's what I mean by the malleable part. You can use a hammer to change its shape, or you can just bend it. That's what we mean by ductile. One of the other, from a chemistry perspective, in addition to these properties, the important thing is that they give away their electrons easily. Metals will real easily give up an electron or more, one or more electrons. That's why they make good conductors. You get electrical current flowing. Electrical current is based on the movement of electrons. If metals give up their electrons easily, they allow the current to flow real easily as well. So on your blank periodic table, I want you to put this label up here. So I've got metals give electrons. Put that on your blank periodic table. And again, that's the green part here that I've highlighted on your periodic table. Now, let's talk about the yellow part next. Right over here in the top right. Our yellow part, these are our non-metals. And what are some characteristics of a non-metal? Well, it's going to be typically opposite of what a metal is. Metals were good conductors. Non-metals are poor conductors. Metals were shiny. Non-metals are dull. Metals, where you could bend them, we could reshape them. They're malleable. They're easily ductile. We can change their shape real easy. Non-metals are brittle, right? They're going to break. If you try to bend up some of this in a solid state, it's going to break. Now, again, opposite of metals, these take electrons from other elements. So metals like to give them, non-metals like to take them. This is going to lead us into some bonding here we'll talk about in our next unit. So again, here I want you to put on your blank periodic table, put up on the top right, non-metals take away electrons. Again, I'm using the color, right? Non-metals are the top right, including hydrogen. It's kind of the oddball. And metals are the left and bottom. They're a big part of our pattern. So that leaves us our last group here, and what I have in blue, and these are what we call the metalloids. Again, these are these colors I had you use yesterday to color in your blank periodic table. And these kind of form a staircase over here. Right? There's 7 here that are in blue. And what are some properties of metalloids? Well, they behave sometimes like a metal and sometimes like a non-metal. They behave both ways. So they have some properties of each, both metals and non-metals. So again, I want you to put that on your periodic table here, your blank one. Just kind of put metalloids here, kind of diagonal, like where that stair step is. So we know our metals in green are over to our left. Our metalloids are kind of a little diagonal strip here, and our non-metals are above it. And of course, hydrogen, our little oddball. Now, there are some special groups I want you to know, right? Because they have names, and they have names because they're very very important in chemistry. And the first group, there are 4 groups here: 1A, 2A, so your column all the way to the left, and the next one in, and then 7A and 8A, the column all the way to the right, and 1 in. Right. So our group on the left, far left, group 1A, we call these alkali metals. Alkali metals. That name's important. I'm going to ask you to memorize that. And alkali metals, what's significant about them? They are very, very reactive. Very chemically reactive, and oftentimes explosively reactive. So on your blank periodic table, I want you to write that in that first column here, that group 1A, put in alkali metals. Our second group to know, again, if I'm going too fast, just pause the video. Our second group to know is group 2, and these are alkaline earth metals. These are also reactive. Not as reactive as the alkali metals, but still pretty reactive. Now, unfortunately, these names are kind of similar. Alkali metals, alkaline earth metals. They're very similar. I wish it was different. It makes it a little bit harder to remember the names, but it's very important that you get these straight. On quizzes and tests, I will ask you to get the right name. Alkali metals is group 1. Alkaline earth metals is group 2. Don't tell me alkali earth metals, because I can't tell what you're talking about. Are you talking about group 1A or group 2A? So spelling somewhat is going to be important here. I need to be able to tell whether you're trying to say alkali or alkaline. So back to your blank version of the periodic table, I want you to put alkaline earth metals in group 2, that second column. Let's move on to the next one here, group 7A. That's the next column I want to talk about. We call, in the middle, before we move on to those. These are our transition metals. And this is the whole group in that middle of the periodic table I labeled with a B earlier. And this is where we transition from metals to nonmetals. So on your blank periodic table right here, this big group here in the middle, just put transition metals here in the middle to help you understand that that's where those transition metals are coming in. They're all this middle part here that's kind of slumped down from the others. Now, after the transition metals, I also want to talk about another group that's important. These guys, like the transition metals, don't fall in a particular column, but these are our rare earth metals. And these are elements with an atomic number of 94. They're greater than 94 and greater. These are man-made. Man-made. Why do I say man-made? Well, you get heavier than 94, you get more massive than 94 protons. The atom is so big, it is not stable and it breaks apart, radioactively breaks apart. And so we know, hope you've heard about that, radiation, half-lives. So some of these metals will break apart, decay very quickly, and we don't see them. That's why we call them rare earth metals. So where are the rare earth metals on your periodic table? That's these two, this row here, these rows here on the very, very bottom, right? They're kind of pulled out. And we'll explain that later on near the end of the chapter, why these guys got pulled out. But rare earth metals are these groups here at the bottom of the periodic table. Now on to column 7A. Column 7A, these are what we call our halogens. These are very reactive, just like our alkali metals are very reactive. Our halogens are very reactive. And we talk about electron structure in a little bit. You're going to see why group 1A and group 7A, our alkali metals and our halogens, are both very reactive. So back to your blank periodic table. Again, I want you to put halogens. Put that in column 7 here, halogens. I drew it going down, just trying to indicate that these are non-metals over here, whereas on the left side they're metals. Just trying to show them the opposite direction. Try to highlight the differences. And finally, for groups 8A, maybe you've heard these before, noble gases. Noble gases. These are inert. What does inert mean? It means they do not react. So when we look at the elements in the right side of our periodic table, group 8, I want you to label those noble gases here. Again, these elements do not react. If you look at your periodic table, helium doesn't react. Neon, argon, krypton, xenon, radon, these elements do not react. They're very stable. And again, we're going to learn about why, based on the periodic table, why we see that happening over there. So your blank periodic table should look pretty much like this. Now we've labeled our groups, we've labeled our periods, we've labeled specific names for groups 1A, 2A, 7A, and 8A, right? Alkali metals, alkaline earth, halogens, noble gases. We labeled our transition metals, we labeled our rare earth metals, we labeled our metalloids. So these are the groupings or the of chemicals of elements rather on our periodic table. But they follow a very similar and repeating pattern. Well, that's it for today. I just wanted to go through this grouping, this understanding, and some names and structure of the periodic table. And we'll continue on with this a little bit more next week. Thanks a lot, guys. Do not forget to do your lecture notes quiz in today's folder, and we will see you tomorrow. Take care. Bye.